Hi, welcome to part 2 on integration by parts. So let's say we want to take the antiderivative of the arctangent of x. Well, to do a problem like this one, it's going to be like the natural log of x. We don't know its antiderivative, so when I'm looking for my u and my dv, because I don't know its antiderivative, I'm not going to plug it in for dv. I'm going to plug it in for u, because I do know arctangent's derivative. So my dv, again, is just going to be my dx. Take the derivative of u, we get 1 over. This just becomes 1 plus x squared dx. V, when I take the antiderivative, we just get x. Using our rule, remember our rule is this, it's u times v minus the antiderivative of v du. So I just plug it in, u times v, x, arctangent of x, minus the antiderivative of v du. Now if I write this, this just becomes x over 1 plus x squared dx. Now how do I finish up on this one? This is where they get a little bit more fun. We have a u substitution. U is going to equal just a 1 plus x squared. Du is 2x dx. Dx is du over 2x. So what am I going to wind up with? X arctangent of x minus the antiderivative. If I plug this in, I get x over u. And look, your x is over u. Get over it. Ha ha ha. Du over 2x, and those x's cancel. And I should be able to go straight to my answer from here. Here we get x arctangent of x minus, this becomes a 1/2 factor of that, and this is 1 over u, which is a natural log of u, which is just 1 plus x squared plus c1. And there's our final answer here. So again, they just get a little bit more complicated. Matter of fact, let's take a look at a really hard one here. Okay, let's take a look at another natural log one. What if we want to try this one? Well, again, it's the same idea. We don't know natural log's antiderivative, so that's going to be our u. The only way you can do natural log is by integration by parts. Our dv is just going to be dx again. So du, take the derivative, we get 1 over x squared plus 1 times 2x dx. Our v, we get x. Taking the antiderivative, we just get x. And I plug it in. My rule says take u, v, so we get x natural log of x squared plus 1. A little bit of mood lighting here. Hold on here 1 second. Let's see if I can. There we go. So we get this x natural log of x squared plus 1 minus the antiderivative of v du. And if I simplify that, I just get 2x squared over x squared plus 1 dx. This is really tough to do. We have to divide here. We haven't done this in a while. So I'm going to take this 2x squared and divide it by x squared plus 1. I'm going to put a plus 0 here for a placeholder. So if I divide here, 2x squared, divided by x squared, I need a 2. Put that over here, so I get 2x squared plus 2. When you subtract, we get minus 2. So this becomes minus 2 over x squared plus 1. So I can now write this as x natural log of x squared plus 1 minus the integral. Instead of here, I'm going to replace it with what we just got, 2 minus 2 over x squared plus 1 dx. These get a lot more fun. I like these problems because they're more like a puzzle for us. We're going to try to solve them. So when we take the antiderivative, we're going to get x natural log of x squared plus 1 minus 2 just becomes 2x minus or plus when I distribute. This should recognize that's our arctangent to arctangent of just x plus c1. Wow, look how long that one is. And that's not going to be near as long as our last one will be. Okay? All right, let's take a look at one more here. We'll see how far we go. Let's take a look at one more here. This is it. The oh my gosh, I need help. This one's spooky. How spooky? I'm afraid of this one. I don't know what's going to happen. Good luck. Alright. What happens if we have two... Whoa, hello. Focus. What happens if we have two transcendental functions, like e to the x times sine of 2x? Well, in this case, it's not so easy, because remember, we normally let u be the algebraic function. In this case, we get to pick. Now, I will warn you, because of the way derivatives work, sine of 2x will make a better u. Chain rule is easier than a u substitution. Our dv, therefore, will be this e to the x, the dx. Take the derivative du, we get 2 cosine of 2x dx. Take the antiderivative, e to the x, and I write it out. U and v, I get e to the x sine 2x minus the antiderivative of v du. I'm going to factor out the 2 here just to make it a little bit easier for us, and hopefully we'll be able to see a pattern. I get e to the x. Remember, all of this is equal to my antiderivative. I get this e to the x cosine of 2x dx. And you kind of recognize, yep, we have to do it again. So I'm going to go and do this again. This time I'm going to let u equal, again, for simplicity. See, if I let u, for simplicity, for the derivative, quotient rule, chain rule is pretty easy, so I'm going to let u be the cosine of 2x, and my dv, again, be the e to the x dx. And this becomes du. See, the derivative is easier. I get negative 2 sine of 2x. v equals e to the x. Whoops, got my dx right there. And I just, again, this is all equal to my antiderivative. So I write it out. E to the x sine of 2x minus 2, big bracket here, u times v, e to the x cosine of 2x minus the antiderivative of v du. Now I'm going to factor out the negative 2, so it becomes a plus 2, e to the x sine of 2x dx. Wow, you know what? Look what's happening here. What I want you to notice is what's happening is that it's become cyclical. It repeats itself. As a matter of fact, look at this. I'm back to where I started from. So I can use it. I don't want, if I keep going again, I'm going to get back here again. So what I can do is this. First, I'm going to simplify this just to clean it up a little bit. I get e to the x sine 2x minus 2 e to the x cosine 2x minus 4 times the antiderivative e to the x sine of 2x dx. Now, remember what I said. All of this is equal to this original integral up here, e to the x sine of 2x. Well, notice this is the same as my original. So once I get to this point where it's just the same exact question, I'm just going to set that equal to the original. I'm just going to bring that all the way down here. And the reason I can do that is because I got this integral, this antiderivative, by integrating this question. And how this helps me is now I can bring over this same term, common term. I'm going to combine like terms. And that's going to give me e to the x sine 2x minus 2 e to the x cosine 2x equal to, be careful, 5 times the integral of e to the x sine of 2x dx. Isn't that cool? Just a little bit of algebra. And therefore, the antiderivative e to the x sine of 2x dx, I just divide by 5. 1/5 e to the x sine of 2x minus 2/5 e to the x cosine of 2x. Don't forget your plus c1. And there is your answer. Wow, that is probably the ugliest thing we'll do all year long. Now, if you go to part 3, I'm going to show you where exactly we get integration by parts. I'll see you then. Bye-bye.